Here we're looking at our section 3.1, and our big essential question for today is how can you use the graph of a quadratic equation to determine the number of real solutions of the equation. So for now we're just going to be dealing with real solutions of our quadratic equations. So our learning targets for today, first we're going to be solving quadratic equations by graphing, then we're going to look at solving some quadratics algebraically, and then we're going to solve some real life problems. So here's where our word problems come into play. So the first thing we need to know is how we can solve these different quadratic equations. So the first thing is when we have an equation in standard form, we can find the x-intercepts and then graph those, and we can also find the vertex. We can also use square roots, and we'll look at if we have a simplified equation where we have this u squared equals d, then we can take the square root of both sides. This will not work if I have this middle term because I can't take the square root of that. So we'll see some examples where we can use square roots, and then we can also factor. And we're going to talk about a couple different ways to factor things. So first we're looking at graphing. So here I see I have x squared minus x minus 6 equals 0. And if I'm graphing and solving, I literally just graph my equation. Okay? So I put my equation in standard form, which it is, and then I graph it. And I see that my x-intercepts are at negative 2, 0 and 3, 0. So those are my two solutions. So solutions when we're talking about a quadratic equation is where my graph crosses my x-axis. So my two solutions are x equals negative 2 and x equals 3 for that one, because I can see from my graph that's where my x-intercepts are. So now here I have the second problem. Negative 2x squared minus 2 equals 4x. So the first thing I need to do when I'm graphing this one is I want to get this in standard form. So I need to get everything to one side. So I subtract that 4x from both sides. So I end up with negative 2x squared minus 4x minus 2 equals 0. So now that I have it equal to 0, now I can graph it and solve it. So here I have a double root, and I see that this is a double root because my vertex is on my x-axis. So I have one solution here at x equals negative 1, and I can see that just by the graph. So now here are some for you to try. Now remember, when we're graphing, we want to get everything over to one side, so it's equal to 0, and then from there we can use our graphing calculator or Desmos to graph them. Now we're going to be using square roots, and I know that for these examples I can use square roots because I don't have an x term. If I had an x term, I'd be better off by graphing it or factoring it, which we'll do in a minute. But since I don't have that x term, I want to go ahead and use square roots. So the first thing I do is I get the thing that's squared by itself. So in order to do that, I add 31 to both sides. So I end up with 4x squared equals 80, right? Because I just add that 31. Well, my squared is not quite by itself yet, so I divide by 4, and I divide by 4, so now I have x squared equals 20. So now that this x squared is by itself, I can go ahead and take the square root. And when I take the square root of something, I always have to have the positive and the negative, so plus or minus the square root of 20. Sometimes we will be asked to simplify my radical. So in order to do that, I want to break it down into its prime factorization. So I know that 20 is 4 times 5. And I know that 4 is 2 times 2. Well, so now that I have it in its prime factors, I can circle any pairs. So since this is a pair, they're the same, my final answer is x equals plus or minus 2 times the square root of 5. Because this 5 goes out here. Since I've circled a 2, it can come out now. Okay, so that's it simplified. I will accept this answer. So if you get stuck something here and it tells you you're not right, just text me or email me and we can simplify them together. Okay, so now let's look at our second example using our square roots. Again, I have to get everything by itself, so I subtract 9 to start with. So I have 3x squared equals a negative 9. Now I've got to divide by 3, so I have x squared equals a negative 3. Well, now I have, when I'm taking the square root, I've got x equals plus or minus the square root of a negative number. So since we are only dealing with real roots here, I have no real roots because we don't want to take the square root of a negative number. We'll deal with that later, but for now we're just talking with real roots. So I have no real roots here. So now let's look at example number C. So I need to get this entire expression by itself before I can take the square root of anything. So I see I have this fraction, so in order to undo that fraction, I want to multiply by the reciprocal, because it's the same thing as dividing by that fraction. So I multiply this side by the reciprocal as well. So now I have x plus 3, that quantity squared, equals, when I'm multiplying fractions, I can multiply straight across. So I've got 5 times 5 is 25. the denominator is 2. So now I can go ahead and take the square root of both sides. So now I have x plus 3 equals the positive or negative plus or minus square root of 25 over 2. So now I can simplify and get this x by itself by subtracting 3 from both sides. So x equals plus or minus square root of 25 over 2 minus 3. So here is another example of where I want to simplify my radical. Okay, so I can go ahead and we're just going to look at this square root of 25 over 2 for just a second. So I've got the square root of 25 divided by 2. Well, I can use my quotient property of radicals and separate that out. So I have the square root of 25 over the square root of 2. Well, I know what the square root of 25 is, so we can simplify that a little bit more. So now I have 5 over the square root of 2. Well, I don't like having radicals in the denominator of my answer because that's just messy and not simplified. So in order to get rid of my denominator here, I multiply by the square root of 2 over the square root of 2. Because remember, anything divided by itself is 1, so I can do that. So now my numerator becomes 5 times the square root of 2. The denominator becomes the square root of 2 squared, which is just 2. So this is how I could simplify this radical. So now I have x equals plus or minus 5 square root of 2 divided by 2 minus 3. So those are my two possibilities. I have a positive 5 times the square root of 2 over 2 minus 3, and then I have a negative 5 times the square root of 2 over 2 minus 3. So those are my two different solutions here. So now here are some for you to try. Make sure that you understand the different steps we have to take to get that x by itself. So now we're looking at our zero product property, and this is how we can solve some quadratics by factoring. So all my zero product property tells me is that if I multiply two things together and they equal 0, then I can set each piece equal to 0 and solve for that piece. So now we're going to solve this one by factoring. So the first step that I have to do is I have to get everything over to one side of the equation. So in order to do that, I just subtract my 45 from both sides. So now I have x squared minus 4x minus 45 equals 0. I always need it to equal 0 before I can factor and use my zero product property. So now I'm going to look at factoring. So the first thing I look at is my a value, and my a value is the number in front of my x squared, and here it's 1. So now that makes my life a little bit easier. Now I want to come up with all the factor pairs of a negative 45. So I know I can have 1 times a negative 45, or I can have a negative 1 times a positive 45. Then I just continue with my factor pairs. I could have 5 times a negative 9, and I could have a negative 5 times a positive 9. All of these will get me to this negative 45. So once I find my factor pairs, right, these are the things I multiply, now I'm going to add them together. Well, if I add 1 and a negative 45, that gives me negative 44. Here I end up with a positive 44, negative 4, and positive 4. We can see here my b term is a negative 4, so that's what I'm looking for here. So I will have this 5 and negative 9. So now I can rewrite my factored equation. So I'm going to have x plus 5 times x minus 9. And you see that my 5 and my 9 I literally take from where I've already worked on, equals 0. Now that I've got this factored, and I see I'm multiplying two things to equal 0, now I use my zero product property. So x plus 5 equals 0, and x minus 9 equals 0, and solve for my x's on both. So I subtract 5, so x equals negative 5, and I add 9, so x equals 9. So my two solutions are x equals negative 5 and x equals 9. And that's how we go ahead and factor these. Okay, so now here's a little bit more complicated one. So we said in that last one my a value was 1. Well, here my a value is not 1. So I can do a couple of different things here. So I can find the factors of all of these and kind of go the long way. I'm going to show you how we can factor this by grouping, which is just a more simplified version of factoring when my a value is not 1. So the first thing I want to do is make sure that all of my terms are on one side of the equation, which they are. Then I can multiply my a times my c, so 2 times 12 is 24. So now that I have 24, I want to go and find all of the factor pairs of 24. So I've got 1 times 24, I've got 2 times 12, 3 times 4, oh, sorry, not 3 times 4, that will give me 12. So I have 3 times 8, and I have 4 times 6. And to get this positive 24, I know that either these can both be positive or both be negative, because that will still give me a positive 24. So now I add these together. So I get a 25, I get 14, I have 11, and I have 10. So again, I can look here in this middle, and I was looking for a negative 11. Well, if I turn both this 3 and the 8 negative, then I have what I need. So now I can go ahead and write out my equation a little bit more. So I end up with 2x squared. That didn't change, and this plus 12 does not change at the end. The thing that changes is this negative 11 becomes broken into 2 pieces. So a negative 3x and a negative 8x. And I know that works because if I add these 2 terms together, it will give me this negative 11x. Okay? So now I can go ahead and group. So I'm going to group this first group set, and I'm adding these. Right? I want to make sure that this negative ends up with the correct term. So now that I've grouped them, I want to look at each set individually. So what do I notice in this first set that I can factor out of each term? Well, I notice that each term has an x, so I can factor out that x. So I'm left with 2x minus 3. So now let's look at the second group. So I see that both of these numbers are divisible by 4, and I notice that I want to deal with this negative here and just make my x positive. So I'm going to factor out a negative 4. So if I factor out a negative 4, I'm left with 2x minus 3. And I can double check that by distributing this negative 4 back in if I want to, or I can, that's the best way to check it. So now the things that I notice and I see, well, I see that my 2 things in my parentheses are the same, so that becomes my first factor. Then the things that are outside my parentheses become my second factor. So now that I have these 2 factors, I set them equal to 0, and I know that because I'm finding zeros. So when you see the word 0 or solution or intercepts, those are all the same thing. So now I'm going to use my zero product property, so 2x minus 3 equals 0, and x minus 4 equals 0, and solve for both of my x's. So I add 3, so 2x equals 3, and I divide by 2. So I have x equals 3 over 2, and I have x equals 4, because I just add 4 to both sides here. So here are my 2 solutions. So factoring can be fairly simple, even if I have this a value that's not 1, if I just follow these steps and kind of group my terms together. Okay, so try that on the couple ones. So really, try that on like this one down here, because you'll notice we've got some really big numbers that we're dealing with. So see if you can group things. That'll make your life a little bit easier. Okay, so now we're dealing with these real world problems, our word problems. So a monthly teen magazine has 48,000 subscribers when it charges $20 per annual subscription. For each dollar increase in price, the magazine loses about 2,000 subscribers. How much should the magazine charge to maximize annual revenue? So first thing I notice is we're dealing with a maximum, which means we need to find the vertex. So and then we're asked what is the maximum. So we're asked the other part of the vertex. So here's what we have to do. We have to figure out our variables. Okay, so here we're using x as the price increase, and r of x, right, our function is going to be the revenue. So now I can write this verbal model and then simplify my quadratic. So I know that the annual revenue is equal to the number of subscribers times the subscription price. Okay, so now I can write down what I know. So I know my annual revenue is going to be r of x equals the number of subscribers. So I have 48,000 is where I start, but I subtract 2,000 subscribers for every dollar increase. And I multiply that times my subscription price, and my original subscription price was $20, and then I'm adding an additional dollar every so often. Okay? So now I have that. I can kind of simplify. So here I'm just going to rewrite the order of my thing, so my x's come first. Then I notice in my first group that I can factor out this negative 2,000, so I'm going to factor that out. And now I have a quadratic equation. So when I'm looking at this quadratic equation, I see I have an a value, and then I have my, this is what we called intercept form, right? Because it's not in vertex form, but it is in intercept form. So now I can find my zeros and find the average, right? Because I know the vertex is exactly halfway between these two zeros. So my zeros are at 24 and negative 20. Because I have to set this up x minus 24 equals 0, and x plus 20 equals 0. So I end up with x equals 24 and x equals a negative 20. That's where these come from. So now I want to find the average of those zeros, so I add them together and divide by 2. So my x value of my vertex is at 2, because this is exactly halfway between my two intercepts. Well, so now that I have this, I can take that 2 and I should plug that back in to my equation and find that my maximum would be a $22 increase. Okay, so now I can find the actual revenue from that. So I take that $2 in that I found that x equals, and I plug that back into my original equation, and I solve that. So my cost to maximize would be $22 cost, and the money that I would make, the most money I can make, is this $968,000. So first I would have to write my equation based on the words. Then from here, it was written in intercept form, so I found the average of my intercepts, so right in the very middle, because that is going to be my my vertex, my x value of my vertex. Then I plug that back in, and I can solve for my actual y value. Okay, so now think about this. What if I initially charged $21 per annual subscription? Now what changes based on my what changes in the whole equation based on this? Okay, so now here's our next word problem. So for a science competition, students must design a container that prevents an egg from breaking when dropped from a height of 50 feet. When we're dealing with quadratics, we're going to deal with dropping problems a lot. So we've got our initial height. One thing we need to keep in mind is that we have to deal with gravity. And so there is a formula that we use that will help us determine the height based on time using gravity. Okay, so here's my big kind of equation that you need to remember. You need to remember h, and we're going to deal with h because it's height, equals negative 16t squared. This t stands for time. It's generally, we're talking seconds, plus, and then my h sub 0. This h sub 0 means my initial height. Okay, so we're going to always be using this equation when we have something of like you drop something or you throw something. We're going to kind of live with this equation and plug in what we know. Okay, so I have to plug in my initial height, which was 50 feet. So there we go. So now I have negative 16t squared plus 50. So I'm asked to find the zeros of the function. So I go ahead and write that function out. I want to substitute my 0 for h because that's where a 0 is. And then I see here I don't have a t term, so I'm going to go ahead and use the square root method. So I subtract 50 from both sides. I divide both sides by a negative 16. And now I take the square root of both sides. So I end up with plus or minus square root of 50 over 16. Then I can use my calculator, and when we're dealing with heights and times, we generally are fine using calculators to estimate. Okay, so I go and estimate my time is approximately 1.8 seconds. So here we want to think too, do I need both of these zeros? I don't, because I can't have a negative time. So I want to get rid of the negative and only have one answer here. So it's going to fall for about 1.8 seconds before it hits the ground. That's the answer to part A. So now part B asks me to find and interpret h of 1 minus h of 1.5. So that tells me kind of, I'm figuring out the difference in height in these two times and seeing what happens there. Okay, so first thing I do is I plug in 1 for t and solve, and then I plug in 1.5 for t and solve. And here are my solutions. So I end up with a 34 and a 14. So I can go ahead and subtract them and see that it's a 20. And here I'm dealing with this h. And we said that h was our height. So this tells me that from 1 to 1.5 seconds after it leaves my hand, it falls 20 feet. So I can also graph that and just double check. So here's me, when I graph my original equation, I can see that. And here's about my 20 feet from 1 second to 1.5 seconds. So I was correct and I was reasonable. Okay, so now think about, what if I initially start at 80 feet? What happens to my other answers from that last problem? So now let's look back at our learning targets. This was a lot of information here. So first we looked at solving quadratics by graphing, and you can use Desmos, you can use graphing calculators, either of those things. Then we looked at solving some equations algebraically. Okay, it's really important that you understand factoring and are able to factor a huge variety of quadratics. So if you're having trouble factoring, please come see me. Then we looked at some real life problems. One thing we really have to keep in mind is if we're dropping or throwing, we have to use that formula from the last page. So now I want you to go ahead and work on this homework for this section.